let's look at this circuit here, and lo and behold, I can make it. Okay. Pretty darn impressive, no? Okay. I just need one more wire. Okay, now if I plug that in there, this is the circuit that's up there. Now the question is, which is brighter, bulb A or bulb D? When I plug that to the battery, which is going to be brighter, A or D? Talk to your neighbor real quick. A or D?
With the switch open.
The switch is open. The switch is open.
Oh, so it have less.
Okay.
More resistance.
What we're really asking is, how does the current split right here, 50-50 or some other way? Well, some other way. But we've got to figure out which path is the easy path. It splits here and comes back together there. So we have to decide which is harder to get through, this or this. Now, in order to answer that, I draw the two the same. If I were to draw this,
Should the switch be on the...
if I were to draw it like that, and if I were to call this branch 1 and this branch 2, I would say the two branches have exactly the same resistance. It would split here 50-50. But that's not the circuit Greg gave you on the exam. Of course it's not. So what's different? Well, this bulb right here. And was it added in series or in parallel? In parallel. What that means is that I'm going to have a smaller resistance here than I have there. Okay? Now, how would I justify that? I would say branch 1 is exactly the same as branch 2, except for the extra bulb C added in parallel. That lowers the resistance of branch 1 compared to branch 2. And that means that when we split the current up here, more than half goes the easy way, less than half goes the hard way. Does that make sense? Let's see if we were right. Of course we are. A is brighter than D. Now, I just want to point out, how much current is going through B compared to A? Half, exactly half. Would you say that B is half as bright?
No.
No. It's not a linear relationship between current and glow. All we can say is more flow, more glow. We can't say twice the flow, twice the glow. Okay, it's just more is more. Now, here's where it gets interesting. What happens to A and D if I close that switch? Talk to your neighbor. What happens?
D gets brighter. No. Yeah, D will get brighter.
Okay.
Oh, there's...
I didn't bring a switch with me, but I can close the switch by just shorting out this bulb E, by putting a wire from one side of it to the other. Now, tell your neighbor really quick, what's that going to do to bulb D, and what's it going to do to bulb A? Okay, let's find out.
Maybe they will go out.
If I short out E, E goes out. D gets brighter, but look at A. Does A care? Does B care? Does C care? No or heck no, people. Talk to me. Heck no, thank you. Okay. Now, that's the one idea that we didn't get to on Wednesday. It turns out, what we just saw here, is that a characteristic of an ideal battery is that any branches that are connected directly to that battery are independent. In other words, if I put boxes around these two branches, if I can find connections to both sides of the battery with nothing but wire, they are going to act as if they have their own battery, as if the other branch doesn't exist. What that means is that I can pull out a bulb here. The bulbs over here change, but those guys don't care. I can smash that one with a hammer. These guys will care. Those won't care. Likewise, I can take one of these out. Those don't care. Folks, that's the way your house is wired. Parallel across the battery. Or in the case of your house, parallel across the power supply. You have a hot line, you got a ground line, and everything's just parallel across that. Okay, from one terminal of the battery to the other. Now, I want to point out that B and C are precarious. B and C are parallel, are they not? Would you say B is parallel to C? Yes, you would. And yet, if I unscrew B, C changes. They're not independent of each other. It's not parallel that makes it independent. It's parallel across the battery. There's two different kinds of parallel. I call them vanilla and tutti frutti. Okay? B and C are just the vanilla kind of parallel. They're just the current either goes here or it goes there. The tutti frutti flavor, the independent, is parallel across the battery. And that's branch 1 and branch 2. Now folks, we don't know today why that is. On Monday, it'll be obvious. On Monday, we'll say, oh, of course. But today it's just an observation. You saw it with your own eyes. You cannot deny it. Okay? You cannot. Now, one of the first things you want to do when you get a messy circuit on an exam is identify which branches are parallel across the battery. That's going to simplify the problem immensely. Because then you know this branch is totally independent of that branch. I can make any change I want to this branch, not going to affect this one in the least. That simplifies the problem.